Okay, today we're going to do the statistics chapter. This is more a chapter about concepts in statistics than actual doing statistical things. So we're going to do a lot of different definitions and a couple examples as well. So we start out with a population. The population of a study is the group the collected data is intended to describe. So a newspaper website contains a poll asking people their opinions on a recent news article. What is the population? Well, that would be the people. A parameter is a value, such as an average or a percentage, calculated using all the data from a population. This is a survey of the entire population. We just had a census this year. A sample is a smaller subset of the entire population, ideally one that is fairly representative of the whole population. A statistic is a value, an average or percentage, calculated using the data from a sample. So population gives us parameters, samples give us statistics. A researcher wanted to know how citizens of Pensacola felt about a voter initiative. To study this, she goes to the Cordova Mall and randomly selects 500 shoppers and asks them their opinion. 60% indicate they are supportive of the initiative. What is the sample and population? Is the 60% value a parameter or a statistic? So the sample is the surveyed people. Population is all people in Pensacola. And 60%, it was 60% of the sample, so this is a statistic. Okay, then we get to quantitative and qualitative data. Qualitative data are pieces of information that allow us to classify the objects under investigation into various categories. Quantitative data are responses that are numerical in nature and with which we can perform meaningful arithmetic calculations. So we might conduct a survey to determine the name of the favorite movie that each person in a math class saw in a movie theater. Is this information qualitative or quantitative? Well, it's the name of a movie. So it's not a quantity, so it would be qualitative. A survey asks the number of movies you have seen in a movie theater in the past 12 months. Is this information qualitative or quantitative? Well, this would be quantitative. It is a number, and it's a number that we can do things with. We can calculate the average number of movies people in the class have seen. We gather respondent zip codes in a survey to track their geographical locations. Is this information qualitative or quantitative? Now it's numbers, but we can't do anything. We can't find the average zip code. So this would also be qualitative. A survey about a restaurant you most recently ate at includes the question, how would you rate your experience with these possible answers? 1, it was awful. 2, it was just okay. 3, I liked it. 4, it was great. 5, best meal ever. Is this information qualitative or quantitative? Well, technically, this can be both. We could figure out an average rating using the numbers, or we could just figure out or classify it by it was awful, it was just okay. So this would be both, depending on how you looked at it. Okay, so now we get into the details. Sampling bias occurs when every member of the population doesn't have equal likelihood of being in a sample. Like if I go to the Democratic National Convention and I want to do a poll to determine who people are going to vote for, well, I'm not getting a very good representation of the general population because pretty much everybody at the Democratic National Convention is going to be a Democrat. So that would be sampling bias. A random sample is one in which each member of the population has an equal probability of being chosen. A simple random sample is one in which every member of the population and any group of members has an equal probability of being chosen. Example 7. If we could somehow identify all likely voters in the country, put each of their names on a piece of paper, toss the slips into a very large hat, and draw 10,000 slips out of the hat, would we have a simple random sample? And yes, we would. Each person has an equal chance of being chosen. Okay, some issues we come up with. Sampling variation. The natural variation of samples is called sampling variability. This is unavoidable and is expected in random sampling, and in most cases is not an issue. So it's going to be off a little bit, but it shouldn't be enough to matter. In stratified sampling, a population is divided into a number of subgroups or strata. Random samples are taken from each subgroup with sample sizes proportional to the size of the subgroup in the population. Suppose in a particular state that previous data indicated that the electorate was comprised of 39% Republican or Democrats, 37% Republicans, and 24% independents. In a sample of 1,000 people, they would then expect to get about 390 Democrats, 370 Republicans, and 240 independents. To accomplish this, they would randomly select 390 people from among those voters known as Democrats, 370 from those known to be Republicans, and 240 from those with no party affiliation. And this is an example of stratified sampling. Sampling is the variation on stratified sampling, wherein samples are collected in each subgroup until the desired quota is met. So suppose the pollsters call people at random. But once they have met their quota of 390 Democrats, they only gather people who do not identify themselves as Democrats. This is an example of quota sampling. So essentially, you would call random people, ask their party affiliation. Once you got to 390 Democrats, if you called somebody who was a Democrat, you would thank them for their time and go to the next person on the list. Cluster sampling. The population is divided into subgroups or clusters, and a set of subgroups are selected to be in the sample. So we divide the people into these groups, and then we select a random sample of the groups. If the college wanted to survey students, since students are already divided into classes, they could randomly select 10 classes and give the survey to all the students in those classes. This would be cluster sampling. In systematic sampling, every nth member of the population is selected to be in the sample. To select a sample using systematic sampling, a pollster calls every 100th name in the phone book. Systematic sampling is not as random as a simple random sample. If your name is Albert Aardvark and your sister Alexis Aardvark is right after you in the phone book, there is no way you could both end up on a sample and yield acceptable samples. Convenient sample and voluntary sampling. Convenient sampling is samples chosen by selecting whoever is convenient. Voluntary response sampling is allowing the sample to be volunteer. A pollster stands on a street corner and interviews the first 100 people who agree to speak to him. Is this a convenient sample? Yes, it would be convenient to just ask people that walk by. A website has a survey asking readers to give their opinion on a tax proposal. This is a self-selected sample or voluntary response sample in which respondents volunteer to participate. Okay, then we talk about some bias, sampling bias, sources of bias. Sampling bias is when a sample is not representative of the population, like the previous example, polling voters by going to the Democratic National Convention and just polling those people. Voluntary response bias, the sampling bias that often occurs when a sample is volunteers. So if you're on a website and you ask your customers, would you take this quick survey asking about your experience on a website? Well, if they bought something from you and it didn't meet satisfaction, they're going to give you a negative thing. And in reality, people are more likely to give negative comments than say, yeah, everything was great. If everything was great, they just go about their business and don't bother with a sample. They tend to only answer surveys of that nature if they are upset about something. Interest study. Bias that can occur when the researchers have an interest in the outcome. I think back to the 70s, cigarette companies had doctors do research to determine whether cigarettes were hazardous to your health. Needless to say, most of those researchers paid by the cigarette companies found that it was not a significant risk. We know better now, but that was things that did happen. Response bias is when the responder gives inaccurate responses for any reason. It could be simple. I ask a group of women, how old are you? Most of them would probably not want me to know their age and would thus say something that's not true. Lack of anonymity. This is when the responder fears giving an honest answer might negatively affect them. If I tell you the truth, you might think poorly of me. Loaded question. This is when the question wording influences the responses. And non-response bias. When people refusing to participate in a study can influence the validity of the outcomes. So let's consider a recent study which found that chewing gum may raise math grades in teenagers. This study was conducted by the Wrigley Science Institute, a branch of the Wrigley Chewing Gum Company. This is an example of a self-interest study, one in which the researchers have a vested interest in the outcome of the study. While this does not necessarily ensure that the study was biased, it certainly suggests that it would subject the study to extra scrutiny. A survey asked people, when was the last time you visited your doctor? This might suffer from response bias, since many people might not remember exactly when the last time they saw their doctor and give inaccurate responses. The survey asked participants a question about their interaction with members of other races. Here, a perceived lack of anonymity would influence the outcome. The respondent might not want to be perceived as racist even if they are and give an untruthful answer. Employer puts out a survey asking their employees if they have a drug abuse problem and need treatment help. Here, answering truthfully might have consequences. Responses might not be accurate if the employees do not feel their responses are anonymous or fear retribution from the employee or employer. A survey asks, do you support funding research of alternate energy sources to reduce our reliance on high-polluting fossil fuels? This is an example of a loaded or leading question whose wording loads the response towards an answer. Those words, high-polluting fossil fuels. Now, if it just said fossil fuels, it wouldn't be a loaded question. that would be okay. Telephone poll asked the question, do you often have time to relax and read a book? And 50% of the people called refused to answer the survey. It is unlikely that the results will be representative of the entire population. This is an example of non-response bias introduced by people refusing to participate in a study or dropping out of an experiment. When people refuse to participate, we can no longer be certain that our sample is representative of the population. So let's talk about observational studies and experiments. An observational study is a study based on observations or measurements. An experiment is a study in which the effects of a treatment are measured. So observational, we just watch what happens and record it. Experiment, we do something and then see what happens. We give them a treatment. So some examples of experiments. Pharmaceutical company tests a new medicine for treating Alzheimer's disease by administering the drug to 50 elderly patients with recent diagnoses. The treatment here is the new drug. A gym tests out a new weight loss program by enlisting 30 volunteers to try out the program. The treatment here is the new program. You test a new kitchen cleaner by buying a bottle and cleaning your kitchen. The new cleaner is the treatment. A psychology researcher explores the effect of music on temperament by measuring people's temperament. So here, something was done, and then we recorded the results. We gave you a drug, we tried a cleaner, we tried a new exercise program. So suppose a middle school, junior high school finds that their students are not scoring well on a state standard math test. They decide to run an experiment to see if an alternate curriculum would improve scores. To run the test, they hire a math specialist to come in and teach a class using the new curriculum. To their delight, they see an improvement in test scores. So there's a problem with this. There's something called confounding. Confounding occurs when there are two potential variables that could have caused the outcome, and it is not possible to determine which actually caused the result. In the case of example 21, there was a new curriculum, but they also hired a math expert. So was it the math expert or was it the new curriculum? We can't really tell. So thus we have confounding. A drug company study about a weight loss pill might report that people lost an average of 8 pounds while using the new drug. However, in the fine print, you find a statement saying that the participants were encouraged to also diet and exercise. It is not clear in this case whether the weight loss is due to the pill, to the diet, exercise, or a combination. In this case, confounding has occurred as well. Researchers conduct an experiment to determine whether students will perform better on an arithmetic test if they listen to music during the test. They first give the student a test without music, then give a similar test while the student listens to music. In this case, the student might perform better on the second test regardless of the music, simply because it was the second test and they were warmed up. So you have to take into account that. One way to get through that would be to have two groups, which is our next concept, control group and treatment group. When using a control group, the participants are divided into two or more groups, typically a control group and a treatment group. The treatment group receives the treatment being tested. The control group does not receive the treatment. If a 2-day prep course would help high school students improve their scores on the SAT test, a group of students was randomly divided into two subgroups. The first group, the treatment group, was given a 2-day prep course. The second group, the control group, was not given the prep course. Afterwards, both groups were given the SAT. A Company testing a new plant food grows 2 crops of plants in adjacent fields. The treatment group receiving the new plant food and the control group not. The crop yield would then be compared. By growing them at the same time in adjacent fields, they are controlling for weather and other confounding factors. Okay, and you've probably heard of this next thing. The placebo effect is when the effectiveness of a treatment is influenced by the patient's perception of how effective they think the treatment will be. The result might be seen even if the treatment is ineffectual. A study found that when doing painful dental teeth extractions, patients told they were receiving a strong painkiller while actually receiving a saltwater injection found as much pain relief as patients receiving a dose of morphine. That just shows you how strong the human brain is. Placebo effect is a dummy treatment given to control for the placebo effect. An experiment that gives a control group a placebo is called a placebo-controlled experiment. So, in a study for a new medicine that is dispensed in a pill form, a sugar pill could be used as a placebo. In a study on the effect of alcohol on memory, a non-alcoholic beer might be given to the control group as a placebo. In a study of a frozen meal diet plan, the treatment group would receive the diet food, and the control group could be given standard frozen meals stripped of their original packaging. Okay, next up, a blind study is one in which the participant does not know whether or not they are receiving the treatment or the placebo. A double-blind study is one in which those interacting with the participants do not know who is in the treatment group and who is in the control group. In the study about antidepressant medicine, you would not want the psychological evaluator to know whether or not the patient is in the treatment or control group either, as it might influence their evaluation. So the experiment should be conducted as a double-blind study. If a researcher is testing whether a new fabric can withstand fire, she simply needs to torch multiple samples of the fabric. There is no need for a control group. So this is the end of statistics chapter. As I said, there's not a whole lot here, just a lot of information. This is to whet your appetite in case you go on into statistics. They'll give you a head start. I will tell you that there will be no straight up definitions on an exam. I don't believe in that. So any material from this chapter, you'll be tested on it by knowing what the meanings are. There might be a question such as the one where it asks, what's the population, what's the sample? Is 60% a statistic or a parameter? That type of thing. So you'll need to know the information, but you won't have to spout it out word for word. So that's it for this. You guys have a good night, and I'll talk to you next time.